Sorry about that. This is going to be awfully close and very personal. Okay, so welcome to the panel on citizen science, and thank you guys for joining us here at SETICon. I want to thank my panelists for joining us today. We've got a great panel to talk about citizen science. Just to give you guys a quick overview of how this will run, we're basically going to I'll do a quick intro of all the panelists so you guys know who's up here, and then we're going to give each of them sort of 3-5 minutes or so to talk about what they do and why citizen science matters to them, and then we'll start some questions. So we might have a few questions from panelists to each other, and then we'll open it up to questions in the audience. Okay, so. To my right, I have Debra Fischer, who's the professor of astronomy at Yale University. She's worked on basically planet hunting for quite some time. Since 1997, she's detected 150 different planets and working with colleagues from a number of universities across the country. So we've got some fantastic stuff to talk about there. We also have Dan Wertheimer. And Dan, I think as many of you probably know, is the co-founder and chief scientist for the SETI at Home project. He directs a number of other SETI research and work at UC Berkeley and has taught courses all over the world. So thank you, Dan, for joining us. Really appreciate it. To his right, we have Jon Richards. Jon Richards writes the software and hardware control systems for the ATA. If you guys don't know what that is, that's our 42 dish array of 6-meter receiving dishes at the SETI Institute. Jon is also working on a project called SETILive, which is taking the data from the ATA and gathering that system and connecting it to some cloud infrastructure that allows people to access that data and interact with it. To his right, we have Ariel Waldman. Ariel is the founder of spacehack.org, which is basically a directory of ways that you can participate in science and space exploration. She's also the global coordinator of the Space Hack Day, which is, I think, expanded to almost a weekend now, which includes basically scientists and people from all over the world coming together to see what they can accomplish in a weekend. So we have a great set of folks, and I will turn it over to Debra to talk a little bit about her work.
Okay, great. Which mic should I use? This one? I can't hear myself, so I'm hoping you guys can hear me. Okay, so I think since this is a citizen science panel, what I'd really like to talk to you about is a project that we started at Yale in collaboration with the folks at that designed Galaxy Zoo, and it's called Planet Hunters. And so just out of curiosity, is anybody here logged on? Woohoo! All right, to Planet Hunters? Oh my God, awesome! Thank you so much. So we founded this as soon as we saw the Kepler data.
There we go.
Thanks. The light curves from Kepler coming out. I realized that this was going to be a great project for crowdsourcing. And the idea here is that psychologists have done studies that show that when you have a group that makes independent assessments, that many times that's much more powerful than even having a single person make an assessment, even if that person is a professional, even if they're trained. And so sort of based on that, we set up this website, planethunters.org, where you can go in and see a Kepler light curve. It comes up. We try to design it in a sort of attractive and easy-to-view way. And you're just asked a few simple questions, usually with icons to prompt you. Is the star variable? Do you see a transit? And if so, then you draw a little mouse box over the transit. And then one of the most powerful parts is, do you want to discuss this star? Okay, and so I think the key, since I only have 3 to 5 minutes, is to say that this has exceeded our expectations for how successful this project might ever be. When we started, I'd go down the halls at Yale and people would say, sorry, but Galaxy Zoo work because you're giving people images to look at, and images are hard for computers to analyze. But when you're talking about signals that have, Fourier, power, then the computers are going to beat the humans every time. And so no one had tried this with time series data. So the Planet Hunters who have participated are co-authors now on 4 papers that we've published with planet detections and with assessment techniques for how we extract the data out the back end. They are powerful super users who go in and actually nurture the new people that are coming along. We actually found before, 3 or 4 months before it was advanced, the Tatooine system, the planet hunters. I went back and looked, and they had a diagram saying, it's an eclipsing binary and there's a planet going around it. And Meg Schwam, who's the postdoc that's amazing working on the system, came to me, and I was like, you know, that's just so improbable. But we have another one now that people are going to be an author on. So how successful has this been? Well, the Kepler scientists say that, you know how much time I put into this project? I spend hours and hours. If you added it all up, it would be weeks, maybe a month of my time doing nothing else but looking at Kepler light curves. The collective of 40,000 to 50,000 planet hunters who have been putting their attention on assessing light curves has amounted to 24/7. You do nothing else. You take no break. You don't eat. You don't sleep for more than 200 years. Okay? And it's that kind of power that's enabled the detection of some things that had slipped through the pipelines before. So I'll just pass it on now to my colleague, Dan.
Thanks, Debra. So I'm Dan Wertheimer. I'm the chief scientist of SETI at home. And I've been doing SETI for about 40 years and been interested in this citizen science stuff for about 15 years. So you probably know that SETI is limited by a couple of things. One is that you need very large antennas. The signals are likely to be very weak. They might come from thousands of light years away. So the bigger antenna, the bigger, we call them radio telescopes, the bigger telescope you have, the better chances you have of finding these signals. So we want to use the world's largest telescope. So we use the one in Puerto Rico, the Arecibo dish. You might have seen it in the movie Contact or in James Bond GoldenEye. In James Bond, it comes up out of the water. It doesn't really do that. But, anyway, so that thing is 1,000 feet across. It holds 10 billion bowls of cornflakes, although we haven't actually done that experiment. And we also use the second largest telescope on the planet is in Green Bank, West Virginia. And we use that because Arecibo can't look at the new planets that have been found by Debra and the Kepler mission. It can't get far enough north. But the Green Bank, although it's a little bit smaller, can see the new planets, so we've been doing searching there. So we have the world's largest telescopes. A problem with the world's largest telescopes is that everybody wants to use those. So we figured out a way to use those telescopes at the same time that astronomers are using them. At Arecibo, for instance, astronomers are doing big surveys of the sky, mapping out the galaxies, doing cosmology experiments, and that's kind of exactly what we want to do in SETI. We want to raster scan the sky and look at millions, billions of stars. And so we go along for a ride, looking wherever the astronomers point the telescope. We don't know where to look anyway. So, and that way we get to use the telescope 24 hours a day, all year round, the world's largest telescope. So that's one of the problems we have, and we've kind of solved that. We get the biggest telescopes, and we get them all the time. But there's another problem that we have in SETI, and that is we need a huge amount of computing time to analyze the data that comes out of the telescope. It's a huge amount of data. We've collected more than a petabyte, 10 to the 15 bytes of data so far that we have to analyze. And that's what got us into the citizen science kind of stuff. In our new projects at the Green Bank, when we're looking at the Kepler planets in the center of the galaxy, we generate 50 terabytes of data every day. It's a huge volume of data. And that would take a huge supercomputer to analyze. And what we used to do before we did the citizen science, we'd still do this, is we'd build these big specialized supercomputers. And that takes a lot of time and money, and by the time you get it built, it's kind of a dinosaur because Moore's law has made it kind of old-fashioned. And so about 15 years ago, we launched this project that I think a lot of you are familiar with called SETI at Home. And what we asked is people around the world, if you have a computer at home or at the office or school, to help us analyze the data from the Arecibo telescope was one of the first ones we used. And what we did is we broke the data up in little pieces, so everybody got a different part of the sky to analyze with their home computer, and everybody got about 100 seconds of data from Arecibo. And you download this free screensaver program. You go to our website, you install the screensaver program, and you get assigned one of these parts of the sky to work on. It might take a few days. And then when you're done, it sends the data back, any strong signals that the screensaver found. It sends it back to our server at Berkeley. Your name is attached to that data. So if you're a lucky one that finds that faint murmur of a distant civilization, you get the Nobel Prize. It's not actually mine to give away, but it might be worth a Nobel Prize. And so maybe you'd share it with me. I'm not sure. The Nobel Prize is it's about $1.5 million, but you won't get rich because there are 8 million people that have downloaded SETI at home. That's maybe 20 cents each or something like that if we share it with everybody. Well, we can argue about who we'd share it with. It is the biggest supercomputer on the planet. If you ask all those people who are helping us analyze the data, they're spread out in 226 countries. It has made the search incredibly powerful, a very sensitive search. We're able to analyze all kinds of signal types that we weren't able to do at much higher sensitivity, 10 times the sensitivity that we could do before without all these volunteers around the world helping us with their computers. And it's a good way to get kids interested in science. We developed a curriculum. As you know, SETI touches on all these questions about biology and evolution and astronomy and physics and computing. And kids are really excited about this question, are we alone? And it's a good hook to get them interested in science. So we haven't found ET, but it is a kind of interesting way to engage people in science. So we haven't found ET, but one of the things that kind of came out of SETI at home was we developed this infrastructure so that people could use their computers for lots of different science projects, not just SETI. And we developed this, it's a big open source project, you might have heard it called BOINC, where you can use your computer at home to not just look for ET, but look for malaria drugs, cancer drugs, HIV drugs. You can search for gravity waves, you can do global warming research, climate modeling research, and you can allocate how you want your computer. There's hundreds of projects. You can say you want 20% of your spare computing cycles to go for SETI and 30% for HIV research, protein folding. You pick the projects you're interested in. And so even though we haven't found ET, I think it's going to be a long time. Don't hold your breath on that. A lot of important discoveries have made out of people that use our software for this volunteer computing, distributed computing, edge resource aggregation. So that led us to develop these citizen science projects like the kind that Debra was just talking about, where instead of people using their computers at home, are asking people to use their brains and their eyes and things that computers are not good at. And our first project was Stardust at Home. Our lab sent a spacecraft out past Jupiter to pick up little tiny particles of dust that were around when the solar system was formed. We wanted to find out how the planets were formed and what those little dust particles were made of. And so the spacecraft went out and scooped up these microscopic dust particles. It came back to Earth. And then the problem is there were a few particles in this big sheets of aerogel foam, but we didn't know where they were. And we would have had hundreds of students looking through microscopes for years to find these little interstellar dust particles. So what we did is we scanned the thing, we made hundreds of millions of pictures, and we asked volunteers around the world to help find the little dust particles by looking at these pictures on their computers. We take a little training thing similar to what Debra's doing, and they found particles we never would have found. And we're finding the first interstellar dust particles and beginning to learn how the planets formed 5 billion years ago in our solar system. So we're starting a new project now called Energy at Home, where we're asking kids around the world to do an energy audit of everything in their home that plugs in, measuring how many watts it pulls and how much your TV pulls when it's off and when it's on, and uploading that information into a big database. We're just trying to get that project together now and raising some funds. So we haven't harnessed the power of 6 billion, I think is the title of this thing. But there are a few million people involved in citizen science, and we haven't found ET yet. There's only a billion people that actually have access to computers on the planet, but hopefully that'll grow, and maybe sometime we'll find ET. Thank you.
Hello, my name is Jon Richards. I work for the SETI Institute, and related to this topic, I have been working on the new project called SETILive.org, and I wonder if anybody here has done that. I think it's quite a few people. So it's brand new. It's a couple months old. We're still trying to perfect it, but what we're trying to do is have the human eyeballs look at data that we're having trouble analyzing at the Allen Telescope Array. So just as a brief overview, we have the SETI Institute has the Allen Telescope Array. I point up. It's up north in Northern California. And we have 42 dishes, and they're each 20 feet in diameter. So they're gathering data 12 hours a day. And there's a lot of data that our computers cannot analyze automatically. because of the radio frequency interference. We have radio frequency interference from, radios, radio stations, TV stations, airplanes, satellites, that kind of thing. And those frequency ranges that we need to ignore because of the interference are tiny, but they're scattered around. So it's quite a significant part of the bands we have to actually skip, because our computer algorithms that analyze the signals coming over in real time, they get messed up and they find too many signals in these bands, and they say, well, this is obviously bad data, and they go on to the next. So we have bands that we've been historically skipping, and we'd like to look at the data in there. So we are using the crowdsourcing, the citizen scientists, with the SETILive.org. So what happens is we've been, the last couple months, concentrating on the bands that we have been previously ignoring, and we don't analyze this data. It gets shipped to the internet, to SETILive.org. And SETILive.org is done by the same people that that Debra's talking about, the Zooniverse people that do the Planet Hunters. So they've developed another project for us. So you get on SETILive.org and you see the data presented to you in what we call a waterfall form, which allows you to look at the data and see a pattern. If you see a pattern, that's quite likely a signal. So you're looking at data you're looking at signals from a spectrum that we haven't ever looked before because we've been ignoring them. So what we get out of it is the people go through and they mark signals that they see, and most of the signals are radio frequency interference. We classify that, we put that into our database, and then hopefully in the future we'll be able to look at that spectrum and we don't have to skip over it. We know where the RFI is, we just skip the RFI that's within that section we're looking at. But also we're having people look at the data to see if they're seeing signals within the data, and maybe somebody will see ET in this data. Quite commonly what they're seeing is signals that look goofy. Like we see a signal that looks like a tire track. Some of them look like squiggles, some of them look like really fat lightning bursts, that kind of thing. So we're seeing about 6 different types of signals commonly. But we're seeing a lot of RFI, and people always ask us, what is this RFI? What is the RFI? And we commonly don't know, but that's going to be the next phase of our project, is to try to actually classify what this RFI is. You know, what kind of satellites is it coming from? And if we can classify those, then we can maybe plan our observations around satellites, so we can observe in those bands when the satellite isn't over us and that kind of thing. So if you have a chance, get on SETILive.org, give us a chance. We're getting ramped up, and pretty soon we're going to get into the state where it's actually your decisions from seeing signals can potentially move the telescope in real time. That means if 5 to 10 people see a signal that meets a certain criteria, we will stop our observations right then automatically and go back and re-observe that object, and you'll kind of get visible feedback. You get badges if you're part of that. You know, people like to have the badges. So so we're going to have that instant feedback, get that good feedback going, and hopefully we'll get more of the world involved in the SETI searches. Hopefully we're going to see some signals. Hopefully we're going to be able to wiggle our way around in the RFI better than we can today. So, thank you.
Hi, so I'm Ariel, and I guess I'll start with very briefly my personal story. I don't have a background in science or technology at all. And randomly in 2008, I stumbled into a job at NASA, which I was not expecting, and it completely changed my life because just never in a million years did I think I was going to work at NASA. I worked for a program called CoLab that specifically wanted to create collaboration between communities inside and outside of NASA. And so I was very lucky in that they were specifically seeking someone who didn't already work at NASA to work on this job. So when I left NASA, I had heard, while I was there, I had heard about all of these different ways in which anyone could actively contribute to scientific discovery and space exploration. But no one I knew had ever heard of any of these projects, and I had never heard of them before. So I created a site called spacehack.org, and it's a directory of ways to participate in space exploration. So everything from things like planet hunters to being able to build a rover that goes to Mars or the moon and things like that. So it's really about communicating that you can actively contribute to space exploration. And these aren't sort of mechanical Turk type things where some scientist is going to take credit for your work at the end of the day. These are things where your name can go on a scientific paper, or you can actually be the creator of a new technology that's used in space exploration, which I find to be pretty powerful. Another project I've been working on over the last couple of years is called Science Hack Day, not Space Hack Day. It's very confusing, I know, but Science Hack Day. And Science Hack Day is a 48-hour event in which scientists, designers, developers, and anyone with good ideas or people who are just passionate get together in the same physical space to see what they can actively prototype in 24 consecutive hours. So it's very rapid fire. And the types of things they make are anything silly to serious. These aren't things that need to be, meaningful contributions to science. They can just be things that you want to play with, things that you get excited about mashing up. We don't really care. It's really up to you. So the types of things that have come out of Science Hack Days have been someone created a really creepy looking mask, and it's supposed to simulate synesthesia, so when your senses get crossed. So it's this mask, and as you walk around a room, different parts of your face start vibrating because in a sense you're being able to feel sight. It was really weird and creepy to look at, but it was also really fascinating. Actually, one of my favorite stories from Science Hack Day that I'll share with you is, since we don't say what people have to work on, someone had made a beard detector, and so they had a USB microscope, and they held it up to their face, and it was able to recognize lines on their face and tell you if you needed to shave. This was very silly, and I was watching this demo, and I was like, oh, that's really cute. I don't know what that has to do with science, but yeah, okay, sure. Whatever you want to do. But we had a particle physicist sitting in the room, and he saw this, and he was like, that's actually a really genius way of being able to record cosmic rays in a cloud chamber. And so actually, from Science Hack Day, he created this proposal to detect cosmic rays in a cloud chamber inspired by a beard detecting microscope. So this is what I love about Science Hack Day and just doing things, is because it's just about these unexpected things, and it's really supposed to be sparks for future collaborations and future ideas. I think there's too much stuff placed on hackathons often to have real outcomes that you can measure and are very serious contributions to society, and I'm totally against that. I'm totally more for having fun and just making weird stuff all the time, and and just seeing where it goes, because you never would expect that a beard detector would go on to contribute to cosmic rays. And weird stuff like that. So that's kind of where my interest is. And so my interest with this panel and talking about citizen science, I guess, is the idea that citizen science isn't just about doing things cheaper or making things more democratized so you can do the same type of science with tons of people. That's definitely a big part of it. But for me, it's really about being able to explore the fringes of science, the things that are unpopular or things that are left behind by bureaucracy, things that might be risky. Funding often goes to very conservative things, and so I think with citizen science and open science, you have more of an ability to tackle parts of science that are otherwise left behind. My other thing is that I think science also needs to do a better job of realizing that they need help from people from all different types of industries and disciplines. So often in discussions about citizen science, it's about people actually doing similar work that the scientists do. But I think also citizen science should also encompass the concept of, space exploration scientists could be using help from fashion designers, or they could be using help from interaction designers, they could be using help from web developers, they could be using help from miners, all different types of people. So for me, it's not just, convincing people you should do science, but convincing people that you can actively contribute to science and space exploration using what you already do, whatever that is. And it's not about having super high-tech skills at all. It's really just about having a passion for getting excited and making things with science. Thank you.
So I had one question for the panel to kick things off, and then we can kind of jump into discussion. I guess we've talked a lot about some fantastic uses of citizen science and lots of different diverse ideas. I'm curious, like when you guys have looked at this space, and you've obviously been in it, and especially Dan, you've been at this for quite some time. Like, what are the biggest challenges to making a citizen science project work? You guys have seen in the projects you've done so far.
I'll take a stab at that. When we first launched SETI at Home, we had $10,000. People were very skeptical that it was going to work. People thought it would be a big problem to that we'd have all these people calling the New York Times. I found ET, I saw a glitch on my screen, and nobody really wanted to get involved. But we got a couple of donations of some computers, and it grew sort of very rapidly. It was, once it got out in the news, it sort of, people started talking to each other, and we couldn't handle all the traffic that was coming in to our little server computer, and we were the biggest user of the internet at the university. It turns out if you plug a computer into the wall, into the Ethernet jack, the university charges $10 a month. So we plugged our server into there, $10 a month, and then we were like bigger than the kids downloading all the movies and everything. And the university had to rethink that policy. And one of the problems we've encountered is most people really want to help. There are all these people that help us write the code, debug stuff, make it go faster, port it to new platforms. There are people that send us money, people that write literature, there's music, there's poetry, there's all kinds of goodwill, and people have sent us all kinds of great stuff. But there are a few people that want to cheat. They want to get credit that they didn't. We thought originally that people would be motivated by helping SETI for just out of goodwill, but a lot of it was like, my computer's faster than your computer, and look at how much work I've done. And there are people that build these big server farms, and crank out the work units. Anyway, there were a few people that try to cheat the system and sort of pretend that they had done work on all these different places in the sky that they hadn't actually done. And so we had to spend a lot of time trying to get rid of, even though it was only a handful of people, that took us a lot of time to put in all that security and kind of keep cheaters from getting credit that they didn't deserve. But it is only a handful of people, but it was kind of painful. I wanted to amplify a couple of things that were said. Ariel was talking about the idea of citizen science doing projects that normally don't get funding and that normally wouldn't get done. And this distributed computing we call the democratization of supercomputing. It's people choose the projects, and if you have a good project that people are excited about, you get a big supercomputer. So I think it's kind of different from the usual sort of model of writing a NSF proposal and peer review. It's a different way of deciding what science gets done. I also wanted to amplify something that Jon was talking about. This radio frequency interference problem is getting to be harder and harder. The radio pollution problem. Arecibo, where we do this work, used to be a quiet place to have a radio telescope, not too many transmitters, but now a lot of the bands are completely corrupted. We can't observe in them by all these transmitters that are encroaching planes, satellites, people with cell phones. We're working on with the South Africans to build a telescope in the desert in South Africa where it's 120 degrees, and so there are not that many people there. But even so, some bands are, and it's getting worse and worse, and the Earth is getting to be a bad place to do SETI, and we may eventually have to go to the backside of the moon, the moon would act as a shield from all the radio pollution of Earth, but that's a very expensive, multi-billion-dollar thing. So this may be a unique window in Earthling's history where we can do SETI, at least in some of the bands, before all the bands are polluted with radio. Great.
Yeah, I got something to say. So, kind of unrelated is the challenges that we've had with the citizen science is this is our actual second citizen scientist effort. The first one was SETIQuest.org. I don't know if any of you have ever gotten on that. And there's a couple people, yeah. So anyway, the problem we had with that is, what we did is we historically we have a lot of people saying, why don't you go open source with your software? Why don't you go open source with your software? So we finally did. We got it to be the right licensing type, and it turns out that it took a lot of effort internally to support that. Once we had the software out there on the internet, nobody really knew how to run it. And a lot of people who thought they had good computer expertise actually didn't really know how to do the computer stuff once it came down to it. And that was kind of confusing, and we didn't have enough internal resources devoted to it. So we quickly learned that if you're going to be doing a citizen science project, internally it takes a lot of buy-in from a lot of people, and it also takes a lot of concerted effort. You have to stick with it. You have to have some resources directed towards it, and you have to keep those resources going. You get them pumping, pumping, pumping. And that on SETIQuest.org, we didn't have that. We kind of went in blind, and we got kind of blindsided by people coming and asking us to pay more attention to them, and we didn't have the resources to do that. So with SETILive, we're trying to take a different approach in that we're trying to set it up so it's automatic enough that we in SETI don't have to be answering questions very much. That we've got it structured so that the Zooniverse people are handling it. We have a guy that's working full time on the project, on our project with Zooniverse, and he's handling the really hard part of the citizen science part is the forums, dealing with people that are having trouble, dealing with people that are angry. You know, the flamers. There's been a couple of flamers on there. Which we had on SETIQuest.org. And Eric there, he's not a flamer. He's our best volunteer on SETIQuest.org, and he helps us out with the flamers still. And you know, we have to get on every day, and there's somebody that leaves goofy messages in the forum, and we, you know, one of our big problems is this guy telling us about we need to buy fancy pocketbooks, purses, right? And if we didn't watch out for this guy coming in all the time, half the forum would be about us that you need to purchase this really fancy kind of purse, you know. And so those kind of people kind of ruin the forums. So you have to have enough resources to keep going. And also, one more thing that we've learned is that with a citizen science project, I think you guys did this right. Once you get the PR going at the beginning, and, you know, and you get thousands of people that are interested, you have to keep you have to keep it flowing. You can't just say, "Oh, we got it started now. Now we can sit back and everybody's going to come our way." You have to be in the news. You have to do exciting things. You have to be blogging, and you have to go out to events. And with the SETIQuest.org, we just kind of went out there and started, and everybody was interested, and then we pulled back and did nothing. And we've also noticed with this new SETILive.org is that at the beginning, they had, I think the first couple of days, 3,000 or 5,000 people sign up. And it was, the first couple of days, I think it was over 100. Was it over 100 people were at any one time? Yeah, huge. They were on the site, and then after a while it dwindled down, and then it went down to where there was always 30 people. And if we don't send out emails, we don't get in the press, we don't do anything, it's dwindling down, down, down. So you actually have to do some continual PR work to keep the numbers up. Until we actually find a signal, then I assume we'll get like 100 million people on it. But that'll crash the servers, so that won't work anyway. So yeah, so with the SETI Institute, I think our big challenge is get it implemented and then keep the PR going to keep the people flowing in, because a certain amount of people are going to come in, very small are going to stay, most are going to go away, but then you need that influx of people coming in all the time.
Great. Okay. So we have some mics here in the room, so if you're interested in asking a question, which it looks like we already have one, please just come up and ask the question.
Tom Dayton from NASA Ames Research Center. This is Sue Blumenberg. She's on the same team. And I want to ask the team up there, your team, if you think it's feasible to use crowdsourcing to do spacecraft mission planning and operations. Now, this is not the science part. You got the science part covered, planning and operations. This is not a hypothetical question. We have mission operations software right now we open sourced a month ago. It's called MCT. Anybody in the audience, Google Open MCT and you can find it. We want to, we're thinking about maybe trying to extend that so we'd have a software package that someone could use for their spacecraft, whoever's, that would somehow help manage crowdsourcing operations and planning. But we just started talking about this. It was Chris Webster's idea in our team, and we're not sure it's a good idea. We don't know. I mean, you can't just say, oh, put out a new version of the spacecraft because we screwed up because the purse guy said, gave us a suggestion and we followed it. We don't know to what degree the computer's resources is what we would want versus humans. Often maybe it's the time crunch, which is when you need that crowd because you've got to make some decision very fast, but geez, then you don't have time to sort through the results. So,
like what kind of decision?
It could be an engineering decision. Battery's low. We got to do something in the next hour or else spacecraft freezes. There are a bazillion possible things to do. We don't have computer power or brain power to simulate all that. We don't know. So maybe only long-term planning is something you could possibly do. But you guys have got a lot of experience in how easy it is to manage suggestions and so on. So any ideas you have would be great.
One comment is that I think the complexity, most of the vast number of people who log on to planethunters.org, and it sounds like this SETI project, SETILive project as well, do something like 10 or 20 classifications. So they might be high school students or something. And the more complex the task is, the fewer, the smaller crowd you're going to be able to tap into. So whatever it is, it has to be a very focused, a sort of a clear, defined request, I would guess. We do have a number of users who are super users who are amazing. I hope I have OCD. They have OCD. They're putting in huge numbers of hours, yeah, it's hard.
So at Berkeley, at our lab, we build a lot of satellites that we launch, and we build like a couple satellites a year. And we have our own kind of operations control center there, probably similar to what you're thinking of. And we have a little dish outside, and we can send up the commands and get the data back as the satellites pass over. And we've been doing that for not just our satellites, but for other satellites because we can do it a lot cheaper than NASA does it. Now, we use open source software, maybe I'm not sure if it's the same stuff that you've written, but we use open source software to track the satellites and figure out where to point the telescope. And we do not use open source software for the commanding, for uploading commands, because you have to be incredibly careful not to accidentally hit the self-destruct button or something like that. So we vet our software very carefully, and only certain people are allowed to go through the door, there's security and card keys and stuff. So I think there's some concern about letting an open community have access to controlling satellites, because these are $100 million things, and you got to be really anal about everything. Mm-hmm. But we do use some open source software, at least in the first part of our acquisition.
Yeah, my opinion would be that type of using a citizen scientist and the crowdsourcing for such a decision would probably be useful if you would just ask people their opinion, and you have a computer system kind of aggregate all that and then report that to the person who actually has to make the decision. So the person can kind of second guess themselves, with what the world generally thinks.
My name is Andrew Masika. I'm wondering if there's an organization, and I'm thinking something along the lines of minorplanet.org, where in that particular case, if you find an asteroid or something like that, you make a sighting, you report it. Oftentimes you're looking for independent verifications of it. And there are a lot of commercially available telescopes that are web-based telescopes are what are going through my mind that are powerful enough for amateurs to get access to. So I'm thinking for transiting exoplanets and things of that sort. would there be similar situations? Is there a similar kind of organization where some sort of reporting system, either by email, hey folks, we anticipate based on some of the other findings through observatories, and we'd like to have independent verification.
Yeah, the one that leaps immediately to mind is transitsearch.org, which is maintained by Greg Laughlin at UC Santa Cruz. And what he's done is he's set up a couple of things. All the known Doppler detected planets, he's calculated prospective transit times, and then people who sign up to the site get an alert, and so they can observe during those times. A lot of times those are sort of long shot cases because the orbits might be long periods, so the chance of having a transiting planet is low. But again, harnessing the power of lots of very talented amateur astronomers with telescopes is really terrific. I'm not sure how active that site is right now, but.
It's very interesting hearing everybody's story. There's so many ideas you immediately start thinking of, and obviously you've been encountering those. And the question of problems is very interesting. I'm wondering, first of all, is there sort of a central collaborative organization among all these that sort of allows different programs to share problems, share solutions, et cetera? That's one thing. And then the question of opening up the problems to the crowd as well, saying, we've got these problems with people using it. Do you have any ideas how we can solve this? So that itself can be outsourced. Then the question of exploiting people at a higher level, even than using their brains to recognize pattern recognition. For example, in the case of, I think there's very creative solutions that are. Remember that we're just starting with this. So, nobody has thought about this long enough to say we can only use people this. We sort of allow. Sure. Maybe we're at crowdsourcing 2.0 or something, but there's 3 and 4 and 5. And the ultimate is to climb people up the chain until they're competing with the scientists, for Nobel Prizes. That would be the ideal. But in terms of like the example of this fellow for the command generation or whatever control. As Ian said, ask them for opinion, but you could do it a little more sophisticated. You could have essentially a simulator, and you could let them. You could have them actually operate a simulator, and out of that, of course, again, it's the question of how much there may be too much, not enough resources. But even that could be that would be harmless. So the citizens could run the simulator. So they could run that program. And then one final thing about sort of like tiny X prizes. Come to the citizens with particular problems. It could be the problems of how to manage the citizens themselves. It could be we need a pattern recognition algorithm for this one thing. Put that out there. You got thousands and thousands of software weenies, and they're itching to take on those problems. Also, the question of open sourcing, which Ian mentions, I am a little bit intrigued that you could have a parallel open source thing where you're not obligated as the program to manage that. You can just harvest something if it emerges out of that. So it could be entirely managed outside the system. You help them set it up. You share the software, and then you say, go to town with it and see if you can do something. And you don't even have to look at it again. You don't actually have to. But anyway, I think we're just at the very start of this, and there's a lot of ideas that have not even been close to mind. Anyway, thanks for your presentation.
So the SETI at Home and BOINC, the Berkeley Open Infrastructure for Network Computing, are big open source projects. And there are big forums where all the developers of the software get together and help each other and figure out new directions of where BOINC and distributed computing should go. And we have annual meetings, usually in Europe, of all the different scientific groups. There's a couple hundred people that use that software, a couple hundred different research groups, and they all come together and sort of plan new directions and figure out who's going to develop what. And so I would encourage you to get involved in that community if you want to help contribute. Oh, yeah. Yeah, sure.
And just to answer for sort of mini competitions and mini challenges, a site that occasionally does scientific problems is Kaggle. Kaggle does essentially computing and algorithmic challenges. So my favorite one was one called Mapping Dark Matter, and they wanted to create better algorithms to map dark matter than the existing ones. And one of the top algorithms that was produced was by a glaciologist who used the algorithms he uses to detect glaciers in satellite imagery and somewhat applied it to dark matter, and it actually beat out some of the existing algorithms, which I found was amazing. So sometimes it's not even, you know, if you have a science background or if you don't, it's just, you know, getting different people to look at problems.
I'm directly and indirectly responsible for a few marriages, some that where we deliberately connected people together. I introduced Geoff Marcy to his wife, but but then these SETI at home groups that come together, they're nerds that meet and get married, and I think I'm responsible for some children on the planet that are not mine.
Well, you had mentioned, yeah, you know, it'd be good if you could just state a problem or say what your problem is and let the community work on it with you not having to do much. That's what I thought we were going to do with our first effort, SETIQuest.org. But it turned out that people actually wanted to have, they were frustrated if they didn't get a lot of support or any support from the SETI scientists. So we put this project out there with all of our source code, and I was hoping that that there would be a community that would foster it among themselves and start on the forum, and they would all get involved with themselves, and I would just kind of tangentially be able to sign on and see what's going on and maybe, you know, answer a couple things. But it quickly kind of came to a halt where they expected more information, and probably rightfully so, from the SETI scientists, more information about the software, how does it work, more than our documentation provided. So that was kind of a failed experiment on our part.
Okay, first I want to thank you. I've used SETI at home and I've done the planet hunters, and it's really exciting, especially looking at those transit curves and the light curves. Even though it's a graph, it feels like I'm looking at a photograph of something. And so along those lines, and I don't know if this is exactly an answerable question, I think it might have to do with the difference between crowdsourcing and citizen science, but I wonder if you choose a priority or how you balance between using the public involvement to help with your science or using the public involvement to get the public excited. Like, is the priority the results that you get or the feeling of connection to the work that the people involved get, and just how you deal with balancing those?
You want to go?
Oh, okay. Well, I was going to say that our first priority was we just wanted more eyes, more people doing research. What we hear from the public is that the #1 reason that they do this is because it gives them a chance to do research. And then a secondary thing was the gratification that we've gotten from not the flamers who are there, but from the people who say, you know, wow, I'm going back to school now. This has made a big difference in my life. So that's just total, you know, gravy. Because I don't know, but I think at least for me, I think for most of us, this is not our primary job, right? This is something that we've done because it seemed like a good idea and it would enhance research. But yeah, and probably the hard thing is that it does take a lot of resources, more than you would imagine, to just keep the engines going. But yeah, to do research is my answer.
I concur.
Yeah, I also think, yeah, we want to do the research, but we also are looking that down the road it might help us with funding opportunities, meaning that our name is out there more and more people know about us, more people will hopefully have a positive attitude. And that would lead into fundings, and SETI needs the funding to keep going with these kind of projects.
I wanted to address the comments from the guy who asked about command and control of a spacecraft and point out that there's something that's almost an analogous example of crowds doing extremely complicated thinking, and that's the World versus Kasparov chess match, which some of you might be familiar with. And there were some really intriguing phenomena that arose during that particular event when there was real expert leadership arose within the community to help direct the game. Kasparov commented that it was the most difficult game of chess he'd ever played, and the world would have won if it hadn't made a very subtle mistake quite late in the game, but it was an extremely close match. And so I think that there are models already for making these extremely complicated and knowledge-dependent decisions in the citizen science or in the crowdsourcing community. And I also don't think that saying that we're playing with $100 million equipment is a good enough excuse to stay away from crowdsourcing, to be honest, and that I think that we're going to get to a point where these sorts of decisions will be made by crowds, even on the scale of $100 million machines and equipment at some point in the future. I think it's just a matter of time that we're going to get to that.
Yeah, it's interesting. I think the computers are now better than a single human at chess, but I bet they're not better than a million humans all working together.
Andrew Masika again. There's the LSST that's going to be coming online in the future, which I think is going to provide some tremendous opportunities for citizen science. And I was wondering if the panel could reflect on the technology and maybe even some of the programs directed towards the public.
Yeah. Oh, so the LSST is the Large Synoptic Survey Telescope, and it's going to be circling, looking. What is it? It makes one track every, let's say, something like few days. The amount of data that comes in is going to be incredible. If you're looking for Kuiper Belt objects, then you're going to see, you're going to be able to get fine time resolution to see them marching against the background of the stars. The amount of data that's going to come out is going to mean a drastic change for astronomy, because when we still, at Yale, right, we have a graduate student program, and we're still teaching them the same things that we learned when I went to graduate school, which is you take galaxies, you study cosmology, you study, it's a regular program, but we're going to need a whole, group of data miners that look at data in a different way and that are clever about this. So I think that's an opportunity. I don't know if it's citizen science or if it's really just an intersection of interdisciplinary computer science and, scientists. But, yeah, it's going to be huge. Fortunately, we have until about 2020 before we start downloading data.
So one of the problems in the nonprofit sector in general is just you have all these people that are really passionate. They want to, they want to go out and save the world and do different things and change the world. But there is a finite amount of resources out there for them, and they're fighting with other organizations that are overlapping in interest in what they're trying to do. And so one of the problems is how do we collaborate and be able to better utilize these resources, and how does that intersect with citizen science?
So if I understand right, you're asking, like, what do you do with a limited amount of opportunities to do amazing things?
Yeah, so as entrepreneurs come around and really want to tackle this arena of citizen science, how can they better collaborate to be able to leverage social impact?
Yeah, I mean, from an individual level, and I'll just speak to my personal life, like, the opportunities don't exist. Like, you have to go and create them. To this day, I'm still practically unhireable because I do so many random different things. And all of the things I've done, no one handed a lot of these opportunities to me. And I'm not saying when I say that, I don't mean I'm like the so many people today who are like, oh, I'm self-made and no one helped me. Of course, people helped me. But, the problem the problem that's being faced is the same problem with a lot of people who are graduating college, in that most of the jobs that are going to be needed just aren't in existence yet. So partially, it is kind of the Wild West of navigating these opportunities. However, I would say some of the best things that have been emerging over the last few years are things like hacker spaces and maker communities, because these are communities of people who really care about learning new things and building new things and really coming together around stuff, and mostly for free. So in some ways they can be seen as like deinstitutionalizing education. In other ways, it's just a community support to really push you to take risk and to explore things that you're passionate about, even if the path in front of you is not very clear. So a lot of the advice that I would give would be actually join your local hacker space and start there. Join communities that are kind of nebulous, and there aren't very straightforward opportunities for you, but you can begin playing around with things, and that's really how I think so many people who change the world end up doing things. They create things, they build things, even if someone's not asking them to. They put it out into the world, and that gets recognition, and over time, it kind of circulates, and that's how you start building up more awareness for the things that you're passionate about changing in the world. So again, it's not the most straightforward answer, but I guess that would be my personal answer.
Yeah, I'm a big fan of meetup.com. So especially in this area, you can go on, and there's probably 1,000 different groups you would like to join, and a lot of them have to deal with open source and any kind of weird technology you're interested in. Somebody's going to have a group, or you can start your own.
And also the Zooniverse, which I think is a phenomenal organization, has fostered all of these subgroups, and every year they take applications for new ideas. So they're branching from astronomy into biology and other fields. So it's a kind of organization that's trying to do that, trying to make more by serving lots of different groups.
Okay, final question.
Okay. Well, as one of those sad, hyper-competitive geeks, it was actually one of Dan's biggest contributors for a year or two by using my employer's servers pre-Boeing. What are the team's opinions on a reward structure that keep people coming back? So keep them interested, what do you give them? It's more than just the joy of discovery. And as a slightly related point, I noticed, I ran a little experiment a while ago, putting folding proteins on all 16 compute cores at home. Calculated, it cost me about $500 a year in extra electricity by running all the CPUs full tilt. Most people's compute surfaces are these nowadays, or tablets. So do you think the future of the crowd computing is going to be more in brain power rather than CPU power donation?
Yeah, interesting.
I could talk a little bit about your motivation question. A large fraction of the people that participate in SETI at home are motivated by credit. That web pages get 2 million hits a day, and a lot of them go to the websites that talk about how much work they've done compared to other people, and we have these teams set up. You can make your own team. There's about 60,000 teams you can join, and schools teams, and large company teams, small company teams, and anyway, the teams compete with each other, individuals compete with each other, and you get credit, which is, of course, worth nothing. It's just little, asterisks next to your name, but that somehow it seems to motivate people. I think the big motivation is people want to feel like they're making a contribution, and so they want to feel like they're part of a science project and that they've analyzed this part of the sky or this frequency band, and that making them know that they've made a contribution is sort of crucial to keeping people engaged, I think. And the other thing that people are clamoring about that Jon talked about is science feedback. So far we've analyzed this part of the sky. These are the strong signals we've made. We're going back to Arecibo to check this stuff. People are clamoring for information. We can't, as Jon was talking about, we don't have enough time. Everybody's busy to kind of give that kind of feedback that we'd like to get back to the users. But so we can't do a good job of that. But I think people would really like that. And Debra also talked about that.
Well, yeah, I'm a big proponent of badges. I like I like to get on the site and get a badge. And you get that, it's embarrassing, but if you get a badge for doing some silly little thing, you get a little adrenaline rush or something like that. So
there are people that auction off their work units, their SETI at home work units on eBay, and they will if you win the auction, they will transfer their credits over to your account, so it'll make you look like you've done a huge amount of work. And these things go for hundreds of dollars.
Wow.
I mean, just to counter this, I would say, it's very important when considering about motivations for people to do things that you provide multiple different avenues for people. Some people are into gamification. I'm usually not one of them. I usually don't care that much about badges or points or credits or anything like that. I just care about like really awesome stuff. And if there's not really awesome stuff, no badge, no points is going to convince me to be motivated about that. And I think they would agree, so I'm not criticizing that. But it's at the end of the day, to me, it's not all about gamification and just convincing people to do more and more. It's about finding the thing, whatever it is, that they are really excited about, or maybe didn't even know that they were excited about, and find really fascinating, and finding that and kind of nurturing it. And I think it's perfectly okay if they come to Galaxy Zoo or Planet Hunters, spend 5 minutes, and are like, meh, it's okay. But the fact that they can say they've played with planet data before, or they've played with particle physics data, that they've actually worked with it, even if they never use it again for the rest of their life, just breaking that barrier is enough of a success to me. I don't expect everyone to be fascinated with science or with whatever science I'm interested in, but I do want there to be the feeling that you could actively get involved in science and participate and find something fascinating about it if you wanted to, and I don't think that's been the case over the last several decades. So there's a lot to be said about just finding really interesting things and not trying to force boring science if it's boring. Different people will find different things interesting, and you have to be okay with that.
Awesome. Thank you to the panelists, and thank you to the audience. Thank you, guys.